Today we'll be going over LINBIT SDS's integration into Apache CloudStack. Today on the panelist list, we have Andrea, who is a cloud architect at ShapeBlue. He's got an extensive background in Apache CloudStack and the infrastructure surrounding it. We've got Yusuf from LINBIT. He's a solutions architect here. And we have Renee, who is one of the core developers of LinStore and our plugin for Apache CloudStack.
Hello, everyone, and welcome to this webinar. And I will start explaining about this this integration with CloudStack with LINBIT SDS. But before starting that, I want to explain why this is important. So LINBIT SDS is the Ferrari of the open source software-defined storage, and it just works. That's not my wording, by the way. This is something that I collected from the users, and LINBIT SDS has many advantages over their competitors, and it's battle tested and a proven piece of software that many cloud vendors are using or in the edge of implementing in their infrastructure. And on the other hand, Apache CloudStack is one of the popular and, again, a battle-tested open source cloud management platforms for mostly in infrastructure as a service. And again, most of the cloud service providers run on top of Apache CloudStack to power their infrastructure. And Apache CloudStack supports many hypervisors such as Citrix, Xen, KVM, VMware, and Hyper-V. And that's why when you combine these two great software, you don't have 1 + 1 = 2. Instead, you will have 3 because you're creating so much value with these open source software. And with this starting, I will hand over to my dear colleague Andrea here from ShapeBlue, and he will explain the Apache CloudStack primary storage to us, and then I will jump into the session, and then I will try to explain the LINBIT SDS a little bit more, and then our beloved developer Renee will explain and show us how the integration works in real world. Okay, Andrea, it's on you now.
Thanks, Yusuf. Hi all, my name is Andrea, as Yusuf already introduced. So, yeah, I mean, for those of you who are not aware of what CloudStack is, this session is actually not going to be a detailed general session about CloudStack. That's something you will be able to hear tomorrow from the CEO of the ShapeBlue, Giles Siret. Today, I'm going to actually just cover primary storage entities, you know, what it is, what it is used for effectively, what the different properties and things around it. So yeah, that's basically it. Right. Can you go please to the next slide, Yusuf? Thanks. So talking about the primary storage, it's effectively your storage pool, whatever technology you might be using, you know, in behind that is used to host live VM images. So volumes of the VMs are located there, and depending on the storage that you use, also VM snapshots are also located there. If you imagine your VMware setup, for example, when you create a snapshot, it is still there on the data store. So when we add new primary storage to CloudStack, we can choose whether it's actually at a cluster or zone level. The image that you see in front of you, you can see actually that there is a dedicated primary storage pool for each cluster in your availability zone. But there is also additional type, if you can change, please, Yusuf. There is additional type of well, not type, but the way to configure primary storage, which is to configure it to be a zone-wide or scope to a zone, which effectively means that all the hosts in all the clusters in your zone, be it 1, 2, or 5 clusters, will be able to access or to create images on that primary storage, which is, as I said, zone-wide. Now, when it comes to the technical solutions, obviously, from the early days, there was NFS as probably one of the first kind of primary storage pools, technology-wise, that you could use. IaaS is also an option. For different hypervisors, we have different kind of what's generically called pre-setup, which means that you manually set it up at your hypervisor level, and then you just feed that information to CloudStack to actually use what's already there, and CloudStack will not mount that storage. It will just try to use it as, with a given name. We also support local storage for what's actually very good for really cloudy, let's say, workloads where you can actually afford that your physical host goes down, that you lose some VMs there, then you are able to spin your VMs, of the same role, for example. It's also interesting. A couple of, I'm not going to say proprietary, but let's say plugin-based storage solutions that are also supported were CloudBytes, SolidFire, Ceph. We can argue it's not really a plugin, but yeah, there is some layer of management of Ceph and creating provisioning RBD images. And obviously we have LINSTOR, which is something that I will leave to Yusuf and Renee to actually demonstrate. Also, when we talk about the cluster, one cluster can have, if you assign, for example, cluster-wide primary storage pool, you can actually attach multiple storage pool to the same cluster. Or as in the image that you see in front of you, you can also have multiple zone-wide primary storage pools that will be used by all clusters. So there is a way to combine it any way you actually need it. And obviously you can set those primary storage pools to be of a different performance or capacity and so on, and then use tiering in CloudStack via certain storage tags and so on to actually route traffic, or not traffic, sorry, to route certain volumes to a certain traffic. We can go to the next one, Yusuf, thanks. Now, the question is, how is primary storage used within CloudStack? Well, as it says on the tin or on the slide, it's basically just a traditional hypervisor storage, whatever way the storage is consumed by that hypervisor, which means that, NFS data store in VMware is just NFS data store. If you add, for example, NFS-based primary storage into your CloudStack installation, same goes for KVM, for Zen Server or XCPNG and so on. Now, when we create a new volume from a template, those volumes are actually linked clones of that template. So we can say that effectively templates become the root volume of the VMs, not literally, but kind of. And those templates are actually copied by the by the hypervisor that's actually used in your environment from the secondary storage, which is a place where you keep templates, ISOs, and so on, to the primary storage when they are requested for the very first time, and later they are cached on that storage pool, so they are never again copied. We just create linked clones, which is by default, default behavior for all major hypervisors. As you can see, for VMware, you can actually opt out to use full clones if you like. So effectively, it's not linked anymore. It's just a copy of the template, complete copy. We also have advanced support for, support for advanced, let's say, storage solutions in VMware like vVols, vSAN, data store clusters, and so on. And also there is a notion of managed versus unmanaged storage in CloudStack. Unmanaged means that you don't need to, as you can suggest, you don't need to manage the storage you're on your own. So you just create your, for example, QCloud2 images on top of NFS or iSCSI LAN with a cluster file system. Or if there is a need to have a plugin within CloudStack to orchestrate and better manage, provide more features that way to the CloudStack from the storage platform, then you usually write your own plugin. And that's true, for example, with LINSTOR, with SolidFire. So we are able to talk via API effectively, or to a control plane on those to create LANs, for example. We can go to the next one, Yusuf, thanks. And yeah, primary storage features. Now, this is just a rough list of the things you can do with, for example, volumes and different actually entities around that exist on the primary storage. So effectively, you can attach and detach data volumes in CloudStack, except root volumes, as it says on the tin. The root volumes are always attached. You can also create one-time snapshots, or you can schedule snapshots. We're talking about the volume snapshots, just to make it clear, not VM snapshots, but about volume snapshots. You can schedule them so they are automatically created on a different hourly, daily, weekly, monthly level to keep certain number of those snapshots, delete the oldest ones, and so on. Also, depending on the storage in question, you have the possibility to actually revert volume from snapshot, sometimes a bit slower like with NFS, sometimes much quicker like with SolidFire. There is also same kind of possibility, if I'm not mistaken, with LINSTOR, which we'll hear later from Rene. Also, you can actually create template from a volume. So when you, for example, install your VM and you configure different things, you can actually convert the first volume, where is the operating system, to a template, and then use this later to deploy multiple VMs. Obviously, resize a volume, no-brainer, but also nice possibilities to migrate volumes to a different storage pool, and that's something you can do either online or offline, meaning while the VM is running, you can migrate the VM depending on the storage and the hypervisor, or you can stop the VM or use a detached volume and migrate it over to another storage pool. And yeah, I think that's pretty much it. If I'm not mistaken, now I'll hand over to Yusuf for the LINSTOR part. Thank you.
Okay. Thank you, Andrea, again. The LINSTOR STS is already explained in the previous webinar. And I mean, I'm not going to go into deep in this webinar. I will just explain how it works basically, and how did we integrate in, how you can integrate into Apache CloudStack. So LINBIT SDS has two components in it. By default, it's a LINSTOR controller, which controls the whole cluster in the hypervisor nodes or the storage nodes. It doesn't matter. And then the second part is the LINSTOR satellite, which you need to install in each and every node. So the LINSTOR controller can manage those nodes, regardless if they are a storage node or a compute node, doesn't matter. And with this combination with LINSTOR controller and the satellite, LINSTOR have a complete view over the cluster. And with that, you can easily create a highly available resources within the cluster. So if you're using, for example, a KVM within the Apache CloudStack and with using the LINBIT SDS within it, and that means you have a DRBD in the replication layer, because LINBIT SDS and LINSTOR is leveraging DRBD for the replication part. And the LINSTOR, the Apache CloudStack can create replicated VMs within the KVM infrastructure. You can have a hyperconverged infrastructures, or you can separate the storage from the compute nodes so that you can have a I always forget the wording for that. Whatever, like separating the storage from the compute nodes style. And so the resource volumes in the LINSTOR is always reflected as a backend disk in the KVM, which leads to Apache CloudStack in this case. And you can migrate these VMs between the hosts with the LINSTOR. And the LINSTOR is integrated into Apache CloudStack with René's efforts and the coding. So right now we have a merged plugin for the Apache CloudStack in the repositories. So when you want to use LINSTOR with an Apache CloudStack, what you need to do, René will explain, but I will explain briefly in here. So first, you need to install the LINSTOR in all hypervisor nodes, obviously, or the storage nodes and everything in your cluster. And you can see on the left-hand side, it's a poor design of what you can have, but it can be more than this, because in this design, you will only see the hyperconverged setup, but it doesn't mean that you can only have the hyperconverged setup. So when you install the LinStore in all hypervisor nodes in your cluster, then you can form a cluster out of the LinStore nodes with the CLI of the LinStore. And then you can install the LinStore plugin into the Apache CloudStack with the documentation, obviously. And then you can connect the LinStore controller into the Apache CloudStack. And then you can modify the storage pools, definitions, replica counts, etc. in both sides. So you can have, for example, two-way replicated for SSDs or three-way replicated for HDD storage pools. I mean, it's all up to your imagination, because LinStore can give you that area freely that you can move on. I mean, you can create different kind of pools, different kind of resource definitions, or like you can create caching mechanism within it, for example, for the HDD part, and so on and so on. So this is like a really high overview of how the stack works. And now I will try to explain the benefits of having this stack, I mean, LINBIT SDS and the Apache CloudStack within your infrastructure. So the first thing I want to say is both sides are open source, which is really important. I mean, open source means that you have the control of your software. It doesn't mean that you code your software, but it means that you have the control of your software, which you can see through it, change it, or I don't know, maybe remove it without any data problems and so on. And both systems are available in many Linux distributions. So you can use it in like many different kind of distributions out there. While LINBIT SDS mostly, not necessarily, but mostly focused on the high performance, low latency environments, and also the edge computing sites. The Apache CloudStack is aimed for different scales of production environments. It can be like a public cloud, private cloud, or hybrid, or it can used in the edge computing also. But what I learn from the community is like Apache CloudStack is mostly used on infrastructure as a service in cloud management platforms. So LINBIT SDS, I already told you guys, it has like many installations in the community. I mean, the millions of installations is actually referring to DRBD, not LINBIT SDS. But what I'm trying to say here is like the technology, the replication technology beneath LINBIT SDS, which is DRBD, is battle proven with those millions of installations, because we are doing this for more than 20 years now. So your data will be secure with LINBIT SDS, that's for sure. And on the other hand, Apache CloudStack is like really simple, really efficient. I try to see through it, and I really can say that it is easy to implement in your infrastructure without any having like huge readings on webs and so on. Both sides are supporting GUI, CLI, and API support, and that's a plus, and that's how we communicate each other, obviously. And LINBIT SDS can support all kinds of workloads. On the other hand, Apache CloudStack only supports VMs because it supports the hypervisors and so on. And the most important thing, if you ask me, I put it in the last, but the most important thing with having these two pieces of software is providing you no vendor lock-in. Because so when you go with the vendor lock-in, you don't have many choices in your infrastructure. So you have to grow in some vendor, you have to do something in order to gain scalability, flexibility, and so on. But that increases your cost, that increases your TCO, and so on, or the return of investment will be much higher than expected, and so on. But if you are using LINBIT SDS and the Apache CloudStack, that means you can mix and match as many as you like. So that's a really good plus. I mean, you can even use your existing hardware. You can use new hardwares with the existing ones. And that's all up to you, because you have the control where you put the data, how you replicate it, and which hypervisor you want to use. How do you want to migrate it? Everything is in your hand. Everything is in your control. So I highly suggest you to give it a try. I mean, that's just good to have it in your infrastructure. And LINBIT SDS has many support for almost all operators, such as Kubernetes and OpenShift, OpenEBOLA, and so on. But we lately integrated with Apache CloudStack, and we are really excited about it. And we are really expecting many infrastructures that will use this integration in the future. And Apache CloudStack, on the other hand, can have multi-hypervisor support, is having multi-hypervisor support, such as KVM, Citrix, Xen, VMware, and Microsoft Hyper-V. So having these two great pieces of software will give you definitely many technical benefits, many business benefits, and you should definitely give it a try. You should think about it. I'm not talking about marketing words here. I'm talking about real deal. The high performance is that you can achieve with LINBIT SDS. We have the world IOPS record with LINBIT SDS. And the flexibility is not just a wording in Apache CloudStack. You can have really flexible environments. So that means if you can combine these two software, you can have like really beneficial environments for your companies or for your customers or whoever you want to serve. Okay, so that's all from me. I want to keep it short. And if you want to know more about the RBD and LINSTOR, you can watch the previous webinars that we did today. Hopefully they will be in our website pretty soon. So please stay in touch. And right now I want to hand over to Renee, my colleague here, and he will do a short demo about LINBIT SDS and Apache CloudStack and how it works and so on. Okay, Renee, it's on to you now. If you're speaking, I cannot hear, just to let you know. No, not yet.
So better now?
Yes, it's better now. It's better now.
Yeah. For some reason, Zoom or anything just switches my audio microphone volume to low sometimes. Okay, back to business. So what I will show you now is well, how to add LINSTOR to an Apache CloudStack cluster, and a bit of how things will look in LINSTOR and how things will behave in CloudStack. I mean, if you're a CloudStack user, nothing will really change for you. You have the usual buttons and functionalities, and LINSTOR should basically work the same as all the other stuff. So what we have here now is one of our test clusters, which has 3 nodes or hosts called in CloudStack. They are KVM hypervisors because that's the only hypervisor we currently support for the LINSTOR plugin or primary storage. So this is a mixed setup. So I still have the let's say default NFS primary storage for CloudStack. But what we'll do now is we will add LinStore as primary storage. Before that, I will also show you the LinStore side. So we have a LinStore cluster with 3 satellites, CloudStack Comp 1, 2, and 3. They have each has a storage pool, which is a LVM thin pool, and capacity of roughly 50 gigabytes. And yeah, they have currently no resource definitions or resources at all. They have a few resource groups, but most of them you can ignore. So the default one, just leave it there. So these are some test resource groups for unit testing, which are not important right now. And in this setup, we will use this CloudStack resource group, which is in the end same as all others, but just give it a nicer name, and also see a separation. So it's also one thing is in a CloudStack setup, what you would match is, or map is, you would map a resource group to a primary storage. So you could have here multiple primary storages of LinStore, but you usually map it to one resource group. And yeah, this, by the way, is a CloudStack 4.16 master or main or nightly build, actually, I think, because LinStore will only be included in the next release of CloudStack, so it's not in the current stable release, so you will have to wait for the next stable release or try one of the nightly builds right now. It's already merged, but you need to use a nightly build. So I'll leave all the zone pod clusters as default, so because I only have one, but if you have a CloudStack user, you know what you will use it for. Then I'll call it LinStore. Then you pick on the protocol, you will have a new point here, LinStore. And you then, as a server, you choose the cloud, sorry, the LinStore controller. So in the simplest way, it's just the IP. You can provide the port, but it will be filled out for you if you don't specify it. And you have to specify the resource group. And we will now use the CloudStack group. And as it's not the only primary storage, I will give it a storage tag, so we can later refer to it. We have tags. And now it will get added. So it's up, connected. This looks okay. Yeah, it will multiplicate from the disk sizes because you have 3 times 50 gigabytes basically. But depending on your replication count. And let's see if I have service offerings. So yeah, I still have the LinStore instance. This is used to map to the LinStore storage. And let's edit this and see. Okay. Disk offerings is what I want. I guess we should be fine. So what I have here is I have a template. I usually, to testing, I use Apache Linux because they are small disks and fast to spin up. And I have a template created here for testing. This is currently on secondary storage, and we will now create a virtual machine out of it, but on the LINSTOR storage. Yeah, I'll leave it empty because CloudStack will do the default one for us. Yeah, I will use compute offering the LINSTOR instance. I just have to check again if it has picked up the right storage tag for us. Oh, let's just recreate it. So, store. Storage fin, yeah, can keep that. Let's say 1 CPU, 500 megahertz, 500 megabyte memory. Leave the rest empty. Yeah, here, and yes, we pick the LINSTOR storage tag. And it's public. Yeah, okay. So, and now we will create a virtual machine of it. Just before I do that, I will show you the LINSTOR side again. There's still nothing here. And we will soon see here some resources created by CloudStack, or by the CloudStack LINSTOR plugin. We will leave we don't use a disk offering here. Disk offering would be an additional data disk for the virtual machine. But for now, we will just use the root disk. We can afterwards create a second virtual machine with a data disk. Let's call it the virtual machine Alpine, and leave everything empty. Oh, I have to pick disk offering. Okay, then let's say 5 gigs.
René, sorry to jump in. I think that you have chosen ISO instead of the template. That's the reason, but yeah.
Oh, okay.
Yeah.
Then okay. And let's see what happens. Okay, so on LINSTOR side, you see at least something gets created. I'm not sure if I did the right thing now, because if I picked ISO, I will have, I will get the setup Alpine and not the already created template.
Yeah.
But yeah, it doesn't make much difference for now, because what we see now is the virtual machine is already started. On LINSTOR side, we have created now a resource which will name CS, which is a prefix from the LINSTOR plugin, and the rest of the part is the UID which CloudStack created for us, which will be the ID from the volume here. So it's CD53 and so on. So we know this is our disk in LINSTOR. And yeah, it's already synced up, and it's on use on comp3, which I guess it's already also running. See, and here we can jump into the ISO. So yeah, we are in an Alpine install. So yeah, I picked the ISO and not the template, but let's just create again another virtual machine, but this time use the template. Oh yeah, I picked ISOs before they're here. And let's call this Alpine from template. Yeah, you have to pick the compute offering for LINSTOR again. Otherwise, it will probably be scheduled on the other primary storage. And this time we don't use a data disk. And launch. So this time a bit more will happen as far as I know. I think first the template will be copied to LINSTOR, and from the template or not. Okay. Oh, no. And then yeah. So what happened now is first thing is the template was copied to LINSTOR, which will be this resource here. And then from the template, as Andre told you before, it gets cached on LINSTOR. And from this resource, we will clone or copy again to the actual root disk of the Alpine install, which will be then this here. So if you go into this virtual machine and check the volumes, so our root is now root 260, and we have the ID 90C24, and yeah, that's exactly this one here. And here we already have a setup Alpine Linux virtual machine running. Just to remember the root password, yeah. But this is running on LINSTOR storage. So what I can show you now from here is some features which LINSTOR or DRBD in the background gives you. So you can live migrate the virtual machine. So just to check, so currently we are running on host comp1, and we will just move it to comp2. So back to the LINSTOR view, we see that the data is used, or the image block device is used on comp1 right now. And if you move it now, you can also check the VNC view. Okay, it gets disconnected. And I have to reopen it. But you see, we moved the virtual machine. I guess it's also written here now that it's on comp2. Yeah. And we have still the same uptime. HJob is still running. And on LINSTOR side, we see that we are running now on comp2. So this works out of the box, basically. Also, the setup is very easy. As you see, you just have to create a new primary storage, pick LINSTOR, tell it what resource group you use and where the LINSTOR controller is running. So this is the address of the LINSTOR controller. Yeah, you can use your only thing what's currently or is not working, that's a limitation of more or less libvirt or KVM, is that you can't do virtual machine snapshots, because LINSTOR provides you a raw block device, and that's not possible right now for libvirt or KVM to make snapshots of raw devices, because it needs a KUKA2 image or some place where to store the RAM memory data of the virtual machine. But you can create snapshots. Okay, seems not from running virtual machines here, but from LINSTOR side, it would be possible to make a snapshot now from this resource. But for demonstration purposes, we just will stop the virtual machine. So it stopped. And before I will show you that there is no snapshots right now. And I'm going to go to volumes and take a snapshot. So snapshots progress.
While it's creating that snapshot, Renee, there was a question about the unused resources in the command line in the terminal. So I wasn't sure if the usage where it says unused, are those, can you explain what those are? There was a question with regards to that.
To what exactly? Sorry, I didn't catch that.
So above where it
usage, the unused usage on the resource.
This column you mean?
Yes.
Yes, sir.
Yeah. Okay. Sorry. Yeah. Yeah. This is so DRBD can only, or yeah, as we use DRBD in the background, DRBD can only be primary or active on one host at a time. There is an exception for live migration, we just showed you. Then it can be used on both, on two nodes, but usually it can only be used on one node. And this just shows you where it is DRBD is currently primary or used. So in DRBD speech, okay, we are now currently on the management server. So on comp2, which is this node here. If I do a DRBD status, oh yeah, this is the other virtual machine because the other one was just stopped. But you see here that this is on comp3 primary. That's what this unused and usage is showing here. So where the block device is currently mounted, I mean, it's not correctly said here, but where it's currently used or opened for read writing.
Okay, thank you.
So yeah, back to the snapshot thing. So yeah, I took the snapshot and we have one snapshot now here in LINSTOR 2. So we could now start again the virtual machine and then stop it and revert back to it and restart the virtual machine. And this also works. So yeah, do we have questions? Because my demo is.
We have one more question. What are other two additional entries created with the resource name? I can answer that. So in DRBD, when you create a resource, you need a replicas in the nodes, then which is you actually you define. In this context, in this particular cluster, Renee created a three-way replicated resources in the LINSTOR. So when you create a node within, when you create a VM in this cluster, that is replicated by 3 in all nodes. So that in the DRBD, you have 3 replicas for each resource. One of them will be used, and the other ones will be unused, as just Renee explained. And that's up to you, because another question says, does a resource need to create on all the nodes? There is no forcefully thing that you can do in the, yes, it can be configured. The replicas can be configured, so you can have 2 replicas, 3-way replicas, or I don't know, 6, 7. We are supporting up to 32 replicas per disk in DRBD. That's up to you.
I will add to the question. Here we set up two replicas, two diskful replicas, and this diskless one,
okay,
this diskless one here, probably was before a tiebreaker, but the plugin will make sure that if you use it on a diskless node, it will become diskful or at least usable. So even if you, let's say you had 4 nodes and you would have 2 replicas, you would get by default a third diskless replica for the tiebreaker, but one node wouldn't have a resource then. But if you would start the virtual machine on the 4th node, which has no resources, the plugin would make sure that a resource is created there, so you can use it also on the node.
Okay, that's cool.
Okay, are there any other questions? Give another minute or two for people to type them out if there are.
Maybe I can ask a question to Rennie. I know the answer, but maybe that will explain something. So you installed the LINSTOR in the KVM nodes, right? So in the same node, you have the KVM and then the LINSTOR and everything. Or how did you set up this cluster? Is LINSTOR separated from the hypervisor, or is it embedded into hypervisor?
The LINSTOR cluster, LINSTOR controller is, so this setup has 4 nodes, but one node is just for management stuff. So on this management node, there is the LINSTOR controller and also the CloudStack management UI and software. And on the other 3 nodes, which is comp1, comp2, comp3, there are the CloudStack agents running and also the LINSTOR satellites.
Okay. Okay, cool. And we have one more question. Any limit for the maximum number of nodes under a resource group?
No, because resource group not really map to nodes. Resource groups are more global object. You can with properties and other stuff, or now let's say with properties on nodes, you can limit where a resource group would be created. Not the resource group, but the resource in the end would be created. So you can have like there's this stuff called replicas on same and replicas on different for resource groups, which you can use properties to specify where you want to spawn a resource from a resource group. So this is example would be if you have a rack and you know this rack, these nodes are in there, and in the other rack are these nodes. Then you set a property on this node in LINSTOR, and with the resource group, you could separate them or make sure that one resource is never on the same node as the other one.
Okay, cool.
Okay, so what about in a LINSTOR cluster? I don't believe there's a node limitation there, is there?
No. So
okay. So I think I believe that's what the questions are with regard to. The next question was, I have 100 nodes in a resource group, but it might be a misunderstanding of how resource groups work and what the nodes are and how they're grouped together.
So no, so resource groups are not direct linked to nodes.
Okay. Yeah. And then the other part was a max replica count of 32, which is correct.
Yeah, but this is a limitation of a resource, basically.
Yes.
I think you want to say, like, I have 100 nodes in the LINSTOR cluster, and I can have 32 replicas, up to 32 replicas per resource, which is a correct statement. You can have it.
Yeah.
The biggest cluster that we've seen until today is like 614 nodes within a LINSTOR, and they have thousands of resources within it, which is I guess a European hosting company is managing it. Yeah.
But in
So
the
it's
usual environment, you will only have, say, 3 or 4 resources.
Yeah.
I mean, per, also replicas per resource, let's say that. Usually 2 replicas are enough, and the third disk less is just for the quorum.
Mm-hmm. Yeah.
And you can also have just 1 resource, but it takes away a few features, because if this one node goes down, yeah, your data is away. So.
And if the node fails, that the compute and the VM is running, and what happens is the VM live migrated automatically in the Apache CloudStack, because there is already another resource replicated within the cluster.
Ooh, I guess you could, maybe a question for Andrea, but I guess you can just start it on another node host. CloudStack shouldn't care as long as it can reach the block device behind.
Andrea?
Sorry, I did not get the question actually.
Okay, so the question was, if a node fails, one of the compute node fails, so the LINSTOR is replicating the data we need, so the data is available in another node, and what happens to the VM? Is it automatically started by Apache CloudStack?
Correct, yes. If the VM is detected to be down, and if the compute offering is set to highly available, then yes, CloudStack should start it on another node.
Okay, that's cool. That's cool. So basically, we can provide high availability to the VMs with CloudStack and LINBIT SDS together.